going on, everybody? So we are going into lesson number 5. Alright, just making sure everything's good on my end. How's everybody's weekend? For the people that are here. Finally had some nice weather outside. We were able to do some stuff. Let's see here. Yeah, it looks like we're just going to do the first page today. And then we got a little bit of stuff tomorrow. Yeah, I like that. All right. I got that all going. I'm still hearing there are some people that are having iTunes problems. If you're one of them, just let me know so I can send you anything that you could be missing. Other than that, I think we should be fine. Just delaying it a little bit. I'm watching my view count jump up, so there's still a few people that are jumping in here and there. So yeah, once again, Unit 11, Lesson 5. We're going to do a little bit more with the trig stuff, mostly just with sine and cosine. I'm going to do a little warm-up with a phrase called down and out that we did earlier this year. We'll see if you guys remember that. So I'll start right off with the warm-up, so that way if there are some people still jumping in, it's okay if they kind of miss this part a little bit. So it says in the warm-up, you have the expression 9 to the 3/2 times 27 to the 1/2 is equivalent to what? And the hint that I said, what do we have to do before we begin to solve? This is where we did something called down and out. So in order for us to actually solve out this multiplication, we're going to change it into radicals. And the reason we want to do that right now is we're not allowed to multiply 9 to the 3/2 times 27 to 1/2 because the bases need to be the same. So we're going to try to get common bases first, and then we should be able to multiply out and figure out what the solution is going to be. Now, we can type this right into the calculator and find the answer, but a lot of times when it comes to tests, they want you to show that workout. So that's why I'm going to show the process. Sometimes when it comes to a test, they do it with variables. So I'm going to do the first one. We have 9 to the 3/2. If I do down and out, what that means is we're going to take the number that is on the bottom of the fraction, we're going to drag it to the outside, and we're going to create a radical. So this is saying that we're going to have the square root of 9, and we still have to the 3rd power because that 3 didn't disappear. Now I'm just going to repeat the process, but I'm going to do it for the next number. So it was times 27 to the 1/2. Again, we're just going to take that number that's on the outside, or I'm sorry, on the bottom, and bring it to the outside. I have my square root. I have the 27, and I still have that 1. And I just realized something. That's not supposed to be 1/2. It's supposed to be 1/3. I must have made a mistake when I wrote this up, so I'm going to change that real quick. This doesn't work out very nicely if I leave it the way that it is. So I'm going to change this so it is a 3. And then it's going to work out a lot nicer. And again, we're going to still multiply these two answers. So in order to solve this, we're just going to do the square root first. So we have to do the square root of 9. And we know what the square root of 9 is because the square root of 9 is really just 3. And we still have an exponent to the 3rd power times. Now when we go to do the next part, now that it's a cube root, it's much, much easier to solve because if it was a square root, we couldn't do that. The cube root of 27 is going to be 3. And it's raised to the 1st power. Now that we did this, we have a common base. So because the bases are the same, there was a trick for solving this out. So I have 3 to the 3rd times 3 to the first. If the bases are the same, they can just stay the same. And then the question is what do we do with exponents when we multiply? Well, when we multiply with exponents, that just means we add them together. So this is the same thing as saying 3 to the 4th power. So that has the same equivalence to what we began with. Well, except that's supposed to be a 3, because like I said, I made a mistake. And 3 to the 4th power, if we were to actually solve it out, just comes out to be 81. Okay. So we did some common base stuff that would have been back in the exponent unit. So we're going all the way back to unit 4, and that would have been back in like November. It has nothing to do with today's lesson, but I still like trying to throw some older stuff in there, keep you guys on your toes. All right. As far as today goes, we're just going to do some more stuff with trig. It's going to be all the stuff that we've done in the last 3 lessons, and we're going to wrap them up and put them all together into this lesson. So the 2 things that we have to remember are what sine and cosine are equivalent to as far as coordinates go. And sine is always going to be your y value, and cosine is always going to be your x value. So what we're going to do is we're going to take that information from the last 3 lessons and we're going to solve it with functions. So all in all, it's going to look complicated because we're going to be doing it algebraically, but we're still doing it with the graphs. We're going to still be doing it with rotations. So I think overall, once I do a couple examples with you guys, you're going to feel okay. If not, obviously I still have the Zoom calls. You guys can stop by and I can do some more practice with you. But let's do a few practice ones first, and then we'll see how you guys feel. So exercise number 1, this is a function. So it says f of x is equal to 6 sine x. It says what is the value of 60 degrees? So first of all, this problem is in degrees. So since it's in degrees, it's not going to be like radians like we did the other day. This one's going to be pretty basic. So because it's in degrees, anytime we have something inside the parentheses, remember that's really the x value. So we could just take that 60 degrees and we can substitute it in for the x. So that's all I'm going to do. We have f of 60 degrees, and I should put the little degree symbol here, is equal to 6 sine of 60 degrees. Now we want to solve this out. Now this can be done on the calculator, but you guys need to know how to do it by hand as well, especially for either course you guys go into next year, whether it's Math 12 or pre-calculus. This needs to be done by hand. The calculator can be used to check it, and I'll show you guys how to check it after we solve it out by hand first. So if I were to solve this out, what we're going to do is we're just going to focus on the trig portion. Just that sine of 60 degrees. The 6 we're just going to kind of leave on the outside because it's not part of the trig. It's saying it's 6 times the sine of 60 degrees. So in order to solve the sine of 60 degrees, we're going to do what we did last time. We're actually going to graph the rotation. So I'm going to graph the x and y axis. I have 60 degrees, which 60 degrees falls in the first quadrant. And then after we created our rotation, I told you guys that we needed to draw a right triangle. So that's all I'm going to do here. I'm just drawing this right triangle. There it goes. So I'm drawing that right triangle in. Now this is one of those special right triangles that we were doing. Now I don't know how many of you guys have these triangles memorized already. If you don't, it's okay. But this was a 30, 60, 90 triangle. So if you need to go back to your old notes to figure out what all the fractions are, you may do so. I'm just going to write them down for here because I do have them memorized, obviously. Across from the 30 degrees is 1/2. across from the 60 degrees is radical 3 over 2, and the hypotenuse is always 1 because we're working with a unit circle. Okay. Now, this question is asking us to find sine of 60 degrees. So this is why I did the little refresher up top. Sine represents the y value. So in this particular problem, the answer that we are looking for is the y value. It's the vertical part of your triangle. So what I am going to do is I'm just going to take this radical 3 over 2, and I'm plugging it in for the sine of 60. And since I'm substituting it in, I'm just putting parentheses around it. Okay? And then we're going to take that and multiply it by 6. Okay? So if there's any questions on how I got that answer, what I did is I just pretended that this 6 didn't exist. I took the sine of 60. I did my graph like we've been doing. I found the sine value, which was radical 3 over 2. And then I just substituted it in so we don't have to work with trig anymore. The trig is now gone. We don't have to worry about it. Now that we have 6 times radical 3 over 2, I'm just going to multiply them. And again, I'm still trying to do this without a calculator. I don't want to use a calculator right now. So what I'm going to do is just take that 6 and put it over 1, and I'm going to multiply straight across. So I'm going to have 6 radical 3 all over 1 times 2, which is 2. The last thing I would have to do is just reduce that. And when you guys go to divide that fraction, that 2 on the bottom can only be divided with the outside number. So we can do 6 divided by 2, which really means we're going to have 3 radical 3. Okay? Now, the reason why I don't want you guys doing this on the calculator is because if you look at that final answer, it has the square root of 3 in it. And when we go to do it in the calculator, we can only get its decimal form. So I'm going to show you guys how you can check it. And it's going to be very similar to how you guys did it with Miss Randolph last year. But I'll walk you guys through the steps. And there's one big thing that we need to focus on. And I'm going to show it to you guys now. So go into your calculator. You can do it right on your iPad. Obviously, I have the swipe because I've been using it on mine. You guys might have to do a little drag and drop. Once you get your calculator open, we're just going to type in that original function we wrote down, the 6 sine of 60. But before we get there, we have to press the mode button, which is right next to the second button. So, and this works on the handheld calculators in school as well. So I'm going to hit the mode button, which will take me in here. And then what I have to make sure, because not all calculators are set to this, is I'm going to scroll down to the part that has operation modes. And underneath, you should see something that says angle. And hopefully you guys can see the part that I'm sliding back and forth. Radian and degree. Since this problem was given to us as 60 degrees, we have to make sure the calculator is in degree mode. So now that I have that degree selected, I can type it in exactly how we have it on the page, and we can check to see if 3 radical 3 was the correct answer. So now I'm going to type in 6 sine 60. When you type it into your calculator, you do not have to put in a degree symbol. Your calculator does have a degree symbol, so you don't have to look for it, though. It's not necessary. And I'm just going to press enter. So it gives me that crazy decimal. I'm trying to check to see if I'm right. The only way I can check to see if I'm right is if I solved it by hand first. So I'm going to type in that 3 radical 3 that we got. And as you guys can see, our decimals are exactly the same. So unfortunately, though we can do this on the calculator, it's not always going to work to our advantage because you're going to get that crazy decimal. When it comes to any math courses that you take from here on out, they're going to ask you to put it in simplest radical form, or they're going to have you put it in terms of pi, depending on if it's in radians or not. Okay. So I walked you guys through it, showed you those steps. Exercise number 2 is the same type of question. Nothing changes in exercise number 2 other than we're not going to be using x, we're going to be using theta. So number 2 is all going to be the same. So if you're still a little bit confused with it, it'll be fine. We'll be doing it again. So I'm going down to number 2. In this one, it says that we have g of theta is equal to 4 cos theta minus 2 sine theta. Then g of 330 is equivalent to what? So once again, I'm just going to take that 330. I'm going to take what's on the inside because that's our x value. And I'm just going to plug them in. And in this case, we're plugging them into theta. So we're going to have g of 330 is equal to 4 cos of 330 minus 2 sine of 330. Because this problem has 2 trig functions, you're still going to do one graph. We only have to graph 330 degrees. But because there's 2 trig functions, we're going to be looking for 2 answers in that one graph. So that's why you guys have to make sure you remember what cosine actually represents and what sine actually represents. So once again, I'm going to create my x and y axis off to the side. This time we're going to be doing 330 degrees. So 330 degrees is going to go all the way down here into quadrant number 4. So the full rotation is 330. But we have to create our right triangles, just like we've been doing the last couple of days. So this part of the lesson is still exactly the same. Come on. So I'm going to draw on my right triangle. Come on, you got it. So it was 330. We have to figure out what that small, tiny little angle is left over. And since a full circle is 360, we know that this has to be 30 degrees more. So very similar to the previous problem, we're going to be working with a 30, 60, 90 triangle again. So across from the 30 is always going to be 1/2. Across from the 60 is always going to be radical 3 over 2. And the hypotenuse is always 1. I'll zoom in a little bit more so you guys can see that. Oh, I froze up again. Whatever. All right, there it is. So we are being asked to find 2 things this time. It tells us that we need to find the cosine of 330, and it's asking us to find the sine of 330. So this is where you have to know your variables. Cosine is represented by the x value, so we just have to find the x value in our graph. The x value is that radical 3 over 2. The sine of 330 is represented by the y value, which is the vertical line, that 1/2. I didn't do it in the last problem because we were in the first quadrant, but we also have to make sure that we're paying attention for negative numbers. In this case, the only one that's going to be negative is the 1/2 because we went to the right. So since we went right, this is positive, but since we went down, this is negative. So I'll put a little negative sign in front of that 1/2. So now what I'm going to do is just substitute them in. So the radical 3 over 2 is going with this first part. So I'm going to have 4 times radical 3 over 2 minus 2. And we said sine of 330 was negative 1/2. So now, just like I did before, I'm just going to simplify it down. I'm trying to do it without a calculator because, again, there's some square roots in here, so your calculator is going to give you all decimals. It won't be in simplest radical form. So I'm just going to put this 4 over 1. I'm going to put this 2 over 1, and I'm just going to multiply straight across. So the first one would be 4 times radical 3 all over 2 minus, actually, this is a negative times a negative, so it would be a positive 2 times 1 over 1 times 2. And then we can reduce those, and it looks like we could reduce the first fraction, 4 radical 3. Actually, Yeah, I'm going to reduce it. It would be 4 radical 3 over 2. We could divide both of those by 2. So it would be left with 2 radical 3 plus 2 divided by 2 is 1. We cannot add those together because one of them is an irrational number and one of them is a rational number. The 2 radical 3 is irrational because if you were to type it in the calculator, it goes on forever. The 1 is going to be rational because it could be written as a fraction and we're done. So once again, you guys can check to make sure that this answer is correct if you really wanted to, because we could type it into the calculator. So I can do 4 cos of 330 minus 2 sine of 330. And I'm going to get that decimal of 4.464, blah, 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 blah. So I'm going to type the same thing. I'm going to type in the answer we just got, that 2 radical 3 plus 1. And as you guys can see, those two solutions are exactly the same. So the check works. Okay. So I just went through 2 questions. I know nobody has really been messaging or saying anything, so I always take that as you guys are doing okay. You have a basic understanding with it. I'm not saying that you guys have mastered this, but if you do have a question, don't be afraid to ask. I'm only going to do one more question with you guys, and it's a little bit different than 1 and 2. It's going to just do some more review with Pythagorean identity, because we did Pythagorean identity in the last lesson. I just wanted to do a little bit more practice with it. And then we'll take a break for today, and then we'll go on to the second page, which is going to be using angles. And it's also angles in degrees, and it's also going to be using angles in radians. So I'm going to show you guys how both those work. All right. So I'm just waiting a little bit because I know some of you guys have a delay. So just in case if you guys do have a question, you guys have the opportunity to ask, but it doesn't look like anybody does. So I'm going to go down to exercise number 3. And this is, and I put the hint in here, it says use Pythagorean identity, but it says it's known that cos theta is equal to negative 0.96, then what must be the value of sine? So in order to find this, we're going to use that Pythagorean identity because we know we're working with a unit circle. So the Pythagorean identity was cos theta squared plus sine theta squared is equal to 1. The only given info in this problem is cos theta is equal to negative 0.96. So I'm just going to plug that in. I'm going to plug that right in here for cos theta. If you didn't do the homework number 4, there was a question like this in homework number 4. So if I plug this in, I'm going to have negative 0.96 squared plus, we can't do sine squared, is equal to 1. So I'm going to type right into my calculator. And be careful, I graded a bunch of your homeworks. Maybe this was homework number 3. I graded a bunch of your homeworks, and some of you guys are forgetting that a negative squared becomes positive. So when you go to write down this next step, it's negative 0.96 times negative 0.96. So the answer has to be positive no matter what. In this case, it looks like it's coming out to be 0.9216. And now our goal is to get the sine all by itself. So I'm going to subtract that 0.9216 over to the other side. And I'm getting 0.0784. So I have sine theta squared is equal to that 0.0784. And then the last step, in order to get sine theta all by itself, we have to square root both sides. So if I square root 0.0784, it says that the answer for sine theta is going to be 0.2 8. Sorry, my fingers are too big. So all I'm doing is I'm using the Pythagorean identity, Pythagorean theorem, and I'm just working my way down, plugging in the information I have, and I'm trying to get the other trig function all along. Okay? So that is all I have for you guys today. So that can give you guys a little bit of a jump start on that homework. There is homework number 5. You'll see that the first problem is working with 30 degrees. It's plugging it in just like we did. The second one is doing it in radians. So if you guys, and even the third one is doing it in radians. So if you want to get a jump start on the homework today, all I'm going to tell you guys is if you see the radians, change it to degrees first. If you change that to degrees, like we did in the last lesson, then you'll be able to solve it just like we did in the lesson. We'll do some more of those tomorrow though. So if you want to wait on doing the homework, we will do a couple practice one with those. But yeah, so if you guys have any other questions, number 4 is just going to be one of those Pythagorean theorems. Number 5 is a degree one. They just want to know which one's equivalent. You can use the calculator to figure out which one's equivalent. Back page is just using Pythagorean theorem again. But again, we can do some more practice with those tomorrow. Okay? So if you want to get a jump start, go for it. Everything should be on iTunes for you guys to download. But like I said, let me know if you're having trouble with it. I'm going to go do a few more things around the house, teach this last lesson, and then I got to do some grocery shopping. We're out of food. So I hope you guys all have a wonderful evening. I will see you guys hopefully all tomorrow. Again, stop by the Zoom if you guys need to. All right. Have a good one, guys.